Welcome back to another installment on a series of videos over system of equation. Without further delay, let's get started. The first question says, product of two positive numbers is 77. It's important to note the two numbers that we're multiplying are positive, okay? One number is 3 less than twice the value of the other number. What is the sum of the two numbers? Well, first, we don't know what those two numbers are, so let's call them X and Y, okay? We know that when they say the product of two positive numbers is 77, that means XY equals 77. And it doesn't matter whether you choose X for this purpose or Y for the purpose, ultimately the answer would be the same. So it says one number is 3 less than twice the value of the other number. How do we translate that into an expression? That's critical. No matter how many problems I can solve and how many videos you can watch, ultimately you have to stop and think and determine whether I can translate this sentence into an expression or not. If the answer comes as no, then you still have to bear the responsibility to figure out why you can't do it. You have to give that a thought, why you can't do it, whereas I can do it. Only when you make that distinction and understand why you cannot do it, whereas I can do it, you'd be able to solve the problem, right? As I said, you can choose either X or Y to solve this portion of the question. So one number is 3 less than, okay, twice the value of the other number. So for instance, let's say we choose X equals twice the value of the other number minus 3. That's what it literally translates to. One number is 3 less than twice the value of the other number. So X equals 2Y minus 3. If you didn't think this, then you have to really think how you're going to solve the problem to yourself, okay? I can keep going like this and solve 10, 15 problems in a sequence of videos. But ultimately, in one of the problems, you have to pause the video and think, how would I do it? And if you can't do it, and if you see me do it, then you have to figure out where is that disconnect. I can teach you, but ultimately you have to think deep in yourself and figure out why does he do it and I can't do it? Where is the disconnect, okay? Some of you may not be able to do this, and I'm telling you, for those who can do it, you don't have to take that seriously. But for those who cannot do it, even after 10 or 15 problems, then you have to really knock on the door and figure out why that's happening. Okay? Now, what is the sum of the two terms? Okay, we know XY equals 77, right? So we can substitute either X or Y in terms of a ratio into this expression. So let's say we know X equals 2Y minus 3. So 2Y minus 3. You can either do it or substitute for X in XY and continue with the problem. So that's essentially 2Y squared minus 3Y equals 77. 2Y squared minus 3Y minus 77 equals 0. This is a quadratic expression, so you have to solve for the value of Y. And I believe it's 14 times 11 is, I think 7. Well, first you have to figure out what is 77 times 2. That's 154, is it? 164, 154. Yeah, 154. So you want negative 154y squared. So you have to multiply two terms, but then add or subtract will give you negative 3y. If you take negative 14y and multiply by plus 11y, you get negative 154y squared. If you take negative 14y and add 11y, then you get negative 3y. So go ahead and substitute this in place of negative 3y will give you negative 14y plus 11y minus 77 equals 0. So if you split this in two halves, take 2y as a common factor, is minus 7 plus 11 would be minus 7. 2y plus 11, y minus 7 equals 0. We don't need to even focus on this because we already told the number is a positive, so y minus 7 equals 0, so y equals 7, because this would give you a negative value, That's why we don't need that. So we know y equals 7, xy equals 77. So x would be 77 over 7 is 11, right? So what is the sum of the two terms? X plus y equals 11 plus 7 equals 18. All right, so this problem has two hurdles. First, you have to figure this expression out. Second, when you get to this quadratic expression, you have to figure out how to factor it. For some of you, that may still be a problem. And if that's the case, then I suggest you go back to my videos on quadratic equations and practice those problems and come back and see if you can do it in a fraction of time to split this and factor it and then plug it back in. From there, it's easy, right? So the two major hurdles are this and this. If you can get over both those hurdles, then chances are you got this problem right on the test. Okay, a charity organization is signing up volunteers to prepare for a fundraiser. Each volunteer can either help set up tables or auction galleries. A volunteer can set up 6 tables per hour or 2 auction galleries per hour. So a volunteer, that is one volunteer, okay, can do 6 tables per hour or 2 galleries, okay, per hour. Okay, if the total is 180 tables and 12 auction galleries, so the outcome is we want 180 tables and 12 galleries, right? If the volunteers will have 3 hours to prepare, how many volunteers must be signed up? Okay, the easiest way to do it is, because the clue here is 3 hours, instead of actually coming to this portion first let's explore how many volunteer is needed for each action, which is table and setting up galleries, in terms of hours. So we know that a volunteer can do 6 tables in 1 hour, right? So 6 table in 1 hour. How many tables could he set up or she could set up in 3 hours? So that'll be 18 tables, right? Right? This leads up to 18 tables. So one volunteer can do 18 tables in 3 hours, right? So that means how many volunteers would be needed to set up 180 tables? You see, the beauty of it is, in one aspect we went forward, in other we're going backwards, right? So 180 tables would be 180 over 18, which is 10 volunteers. 10 volunteers are needed to set up 180 tables, right? Now let's go to the auction galleries. So a volunteer can do 2 galleries, okay, in 1 hour, right? So he or she could set up, I guess, 6 galleries in 3 hours, right? If 6 galleries can be set up by, one volunteer can set up 6 galleries in 3 hours. You have to keep saying that in your mind because we've already taken care of the 3 hours. So 12 galleries would need how many volunteers? So that will be 12 over 6 is 2 volunteers, right? You're asked to determine how many total volunteers must be signed up to accomplish both of these tasks. That means you need 10 volunteers for the table, 2 volunteers for the auction galleries. So you need a total of 12 volunteers. Okay. You literally have to dissect the problem to its bare bone to figure out how you would do it. If you can think of even a better way than I have explained, please suggest that to me in the comment box below. In my opinion, when I solved this problem, these are the steps I had taken to solve the problem, and this is how much time you would have taken for me to solve the problem. Okay? You want to be at least in the ballpark of the time it takes me to solve the problem, so that on a test you could even be a little more faster and save some time. Okay, Joey has $1.50. If he only has quarters and nickels and he has 14 coins total. How many nickels does he have? Again, we have one track which goes in terms of dollars, and other is a physical count, right? Let's say we assign X to quarters. Again, the count and the money, which is the dollar sign, is not the variable. It's the quarters and the nickels. So let's say X is quarters, Y is nickels. Maybe that's the easiest way for you to do it, is figure out what is the variable. It's not the count, that is how many, and it's not how much money. It's the quarters and the nickels, because the quarters and the nickels have different aspects, different composition to them. Okay, a quarter is 25 cents, which is $0.25. Okay, a nickel is 5 cents, so it's $0.05. This composition is what makes these two a variable, not how many are present or what does it add up to. Of course, if you have different amounts, the total amount is going to be different. That's not very surprising. And if you have different count, then also your total amount is going to be different. So the count is not surprising as well, but the composition, it's the inherent nature of the quarters and nickels what makes them the variable. Okay, so we know X quarters plus Y nickel is 14. That's the count, the physical count. That's 14 coins total. And then the second is 0.25. The dollar of the quarters goes with X, so 0.25X, and 0.05 is nickel. That's Y, equals $1.50. Again, I'm eliminating the dollar signs for convenience. So we can substitute either Y in X or X and Y, doesn't matter. I'm just going to do 14 minus X. So 0.25X plus 0.05 times 14 minus X equals 1.5, right? I just substituted in place of Y. So 14 times 0.05 is, 14 times 0.05 is 0.7 minus 0.05x equals 1.5, 0.25x. So 0.25 minus 0.05 is 0.2x equals 1.5 minus 0.7 is 0.8. So 0.2x equals 0.8x equals, I think it's 4. Yeah. So he has 4 quarters, right? So X plus Y equals 14. This corresponds to quarters. So 4 plus Y equals 14. So Y equals 10. Okay. If you need to proof check your work, you can do that. That will be basically 4 times 0.25 plus 10 times 0.05. See if that adds up to 14. If it doesn't, then you've made a mistake. So 0.25 times 4. Sorry, that should add up to $1.50. So that's $1 plus 50 cents. So $1.50. So I've done my math right. So how many nickels do we have? 10. So again, the critical aspect is deriving this expression. You have to know what is the variable. The coin count is not variable, nor the total amount of money that Joey has, which is obtained by how many nickels and quarters have. So that is also not the variable. It is the inherent composition of what quarters are made of, what nickels are made of. For those who are not Americans or who are not used to quarters and nickels, a quarter is 25 cents. Let me write it somewhere here. 1 quarter is 25 cents, and 1 nickel is 5 cents, and 1 dime is 10 cents. 100 cents make $1. Here's the conversion that you need to know if you're not American, or you've not lived in America, or you're not used to currencies outside of your home country. So for those of you, I've given you that conversion factor. Okay, f of x equals 2x squared minus 3x plus 1, g of x equals 13 minus x. What is the distance between the points of intersection of f of x and g of x? This is a very lengthy problem, even though it's a very easy problem. So as I've mentioned before, if 2 points have to intersect, then f of x must be equal to g of x. This is the tip that you want to know. Okay, that means 2x squared minus 3x plus 1 equals 13 minus x. So that means you can substitute x equal, or I guess you can do 2x squared minus 3x plus x plus 1 minus 13 equals 0. So 2x squared minus 2x minus 12 equals 0. So if we take 2 out, x squared minus x minus 6 equals 0. 2 becomes irrelevant. Again, if you're not sure about quadratic equations or you're still having difficulty, I suggest you go to my videos on quadratic equation. There's quite a number of problems for you to practice. Each has its own flavor. I suggest you go and watch those videos. So if you do it this way, so it'll be x squared minus 3x plus 2x minus 6 equals 0. So x times x minus 3 plus 2 times x minus 3 equals 0. So x plus 2 times x minus 3 equals 0. So x will be negative 2, x will be negative 3, right? So how do we find the distance between the two problems? What's distance? Well, we know that the origin is well, points of intersection. What's the distance between points of intersection is, let's do distance is what, x squared, x2 minus x1 squared plus y2 minus y1 squared, right? So okay, so if you know that what we have solved is, if you say f of x equals y, that means y equals 2x squared minus 3x plus 1, right? So for this, you have to substitute the x you got into the one of the expressions, okay? So that means, or you can do y equals 13 minus 1. You can substitute x in one of them, right? This is 13 minus x. So if you substitute y, x equals plus 3, I'm sorry, it's negative 3, right? So y equals 13 minus, if you substitute x as minus 2, it's plus 15, right? So if x is minus 2, right, y is 15, right? This is, say, x1, y1. Similarly, if you substitute, as I said, you can substitute in either one, you get the same answer because we've assumed this expression here, right? So that means, again, let's say y equals, when x is 3, it's 13 minus 3 is 10. So if x is 3, y is 10. Again, another thing you have to remember is, we are saying the f of x is a function that's equal to y. Only then you know, okay, that is where the y is coming from. So there's a lot of, simple things you have to know, or complex things if you think that is complex. So if you say this is x2, which is 3, then its corresponding y value is 13 minus 3, which is y2, which is 10. So now the distance formula is x2 minus x1, which is 3 minus 2, which is plus 2 squared, plus y2 is 10 minus 15 squared. So that is 5 squared plus, again, this is negative 5 squared as well. So that is 25 plus 25. I guess you can say it's 25, right? So that's what, 50. So that is 25 times 2. So that is 5 root 2. It's a lengthy problem. I'm afraid a lot of the problems in this series of videos on systems of equation are lengthy, and this is why you expect these type of problems towards the end of a test. So if you already feel you got a 98 percentile and you have just this problem left, you don't have to even do it if that's how confident you are. For those of you that just want to learn and be successful, then just continue watching. Okay, these are not difficult problems, but at the same time, these are not also easier problems. So there are a lot of takeaways here. There's this takeaway, and then assuming f of x equals is another takeaway. This is the distance formula, something which you have to know, and you also have to know how to do quadratic. So 4 takeaways in one problem. That may be a little too much for a novice person, but that's why I'm identifying those. As you do these problems, You have to get into a mindset of knowing, okay, what are the critical components of the problem? What it is that I need to know, what it is that I don't know. You have to basically close all the knowledge gaps in your existing schemes, then you can further simplify. And then as you become more comfortable, then you're going to be able to solve the problem. Okay. Sally spent $5.75 on pens and pencils for school. So we know the cost is $5.75. So the dollar is not a variable. Each pencil costs 25 cents and each pen costs 50 cents. Well, the pencil and pen themselves are variables, which is easier in this case. If the number of pens Sally bought is one more than number of pencils. So here's how you do it. First, you want to assign X to, I guess, pens and Y to pencil. Doesn't matter which one you assign X and Y. Okay. So we know that 25 cents is $0.25, right? 25 cents is $0.25 and 50 cents is half a dollar, right? So if the number of, so essentially what she has, number of pens is one more than number of pencils. So X is Y plus one, right? Isn't that right? Right? X is Y plus one, right? In the previous problems, we had separate count for one variable and we also had separate either currency or whatever be it for the other. In this case, the count is the number of pen is one more than number of pencil. We said number of pen is X, so X is Y plus one, right? And let's do the 0.25. The dollar here corresponds to pencil, which is Y. Keep in mind, this is Y, this is X. So 0.25Y and 0.5X, okay, that corresponds to pen. That's equal to 5.75, which is the total cost. Again, we know X is Y plus one, so we can substitute 0.5 times Y plus one plus 0.25Y equals 5.75. You see, this is the same concept, but you see how subtle they're different as well. 0.5Y plus 0.5 plus 0.25Y equals 5.75. This adds up to 0.75Y plus 0.5 equals 5.75. So 5.75 minus 0.5 is 5.25. So 0.75 equals 5.25. So that divided by 0.75 is 7. So Y is 7. What is Y corresponds to? Pencils. So Y corresponds to pencils, right? Which is 7, right? So how many pens did she have? 7 plus 1. So that means she had 8 pens. What's the total number of pencils and pens she bought? Is 8 plus 7 equals 15. So this problem, unlike the previous problem, which had so many takeaways, this only again has one takeaway, which is this and this. These are the only two takeaways you have, right? The park is full of people walking their dogs. If Mary counts 45 heads and 140 legs, how many dogs are present in the park? Again, this is very similar to the sheep and chicken problem that we did earlier. Okay, let's say the dogs and humans are, right? It's for people and dogs. Those are the variables, okay? Right? Because, well, those are variables because their inherent composition is different. People have 2 legs, dogs have 4 legs. So, okay, there are 45 heads. So let's say the head is, they both have 1 head. So X plus Y. Again, X corresponds to, I guess you can say people, because those are the variable. Y corresponds to dogs, okay? Head, which is 1 head for each, whether it's a human species or dog species, the head is, they have only 1 head. So 1 head for 1 X, 1 Y for 1 dog equals a total count of 45, okay? Humans have 2 legs, so 2X plus dogs have 4 legs, so 4Y equals whatever the head value, the leg value is 140. Okay, now we know x plus y equals 45, 2x plus 4, 5 equals 140. Again, 2 is associated with x because x is associated with people, and 4 is associated with y because y is associated with dogs. It's very important what you assign x, y to. Okay, now you can simplify this by multiplying by 4 throughout to get rid of either y, in this case, which will be 4x plus 4y equals, what is it, 45 times 2 is 180, because 45 times 2 is 90. So 45 times 4 is, 180 equals, and then you have 2x plus 4, 5. I didn't even change it because I can just simply get rid of y. 2x equals 40, x equals 20. We said x is people, but they're asking how many dogs. So we know x plus y equals 45. If x is number of people, the number of dogs would be y equals 45 minus 20 is 25 dogs. Isn't that simple? So again, the takeaway here is writing the algebraic expression. Other than that, it's pretty straightforward. Okay, so if you've learned something, consider subscribing to my channel. Please share the videos with your friends and family members. And thank you for watching. I'll see you with another video on the topic of systems and equations. So stay tuned.